Welcome back, chaps. Okay, back to another part of this project, BMW, the R9T. Now, I think where we left off last was we were intending or hoping we could fit a single Smith's kind of style early looking speedo in that headlamp bowl. Now, the issue is this is a 2015 bike, and as is most stuff nowadays, generally we're on a Canbus system. Now, I'm not an expert on Canbus. I've got a basic knowledge of it that I kind of understand, and we're just going to touch on today, but we're really not going to get technical into it. Basically what we've got is, on any Canbus network, we have CAN transceivers on the network. This is the network, okay, and at the end of the network there's a 120 ohm terminating resistor, and at the beginning of the network, if you like, there's another 120 ohm terminating resistor. So with resistance in mind, if we'd only got 120 ohm resistor, if we measured the resistance, it would be 120 ohm. But on this network we've got two 120 ohm resistors, so it doesn't take it to 240, it reduces it to 60. That means, with that said, if we remove one of these terminating resistors out of this network, it can no longer terminate data packets, information being sent along it from one brain to another along the network, and the network fails. So a way of testing any CAN network, whether it be on a car, a bike or whatever it is, to actually test the resistance in the network, which should be 60 ohms. Okay, that's enough of the, you know, these are basically brains, i.e. engine management or ABS, or if this was a car network, for instance, you're trying to think of it like a self-restraint system, airbag system, anti-lock brakes, blah blah blah, all that. So these are all different brains talking to each other, sending required information in data packets, as I said, down this CAN system. Back to our BMW. Okay, we want to remove these clocks if possible. Now, the reason I mention this is, if the terminating resistor, this 120 ohm resistor, is in the clocks, I'm going to say we can't do it. We probably could with some whiz kid taking it all to bits and finding the resistor and doing whatever, but I'm really not getting into that. The bottom line I need to know for this is, if our 120 ohm resistor is in the clocks, then we need to carry on using the clocks. But when you think about this, there's only 6 wires in the back of these clocks, and if I turn it on, we've got gear position, RPM, speed, a lamp monitoring clock. We've got the indicators, we've got high beam, blah. So you imagine the whole, how many circuits there is going on in these clocks, and yet feeding it there's only 6 wires. And one of those is alive, a 12 volt feed, and one's an earth. So if you think about it, how is this set of clocks getting all the different information off the bike down only 6 wires? Because it's using this CAN network. Each brain is sending the signal down the CAN network, and this is a brain in itself. It's not just a set of clocks like the old days of it. This is actual brain itself. Okay, now that we've got an ABS pump here just at the back, probably just a bit out of reach of the just turn the ignition off, a bit out of reach of the camera at the minute, but it's also supplied with a wire there. So what we're going to do, for me to know and us to see, make sense of this, what I've just said, again, it's witchcraft. So we're going to go on we've got an oscilloscope rigged up, okay, which I rigged up for number 1 to see whether we had got Canbus, but as soon as I saw there was only 6 wires at the back of there, I knew anyway. But we'll just look at CAN high and low data transmission, okay. So we're on a 5 volt scale, we're on the green and yellow channel, it's dead at the minute. I turn it on, what we get is, we see data packets. Now all them little blips there are information, the packets of information along the network. One of them is going to be that the immobilizer and the key reader sees it's the correct key, so it's allowing the ECU to start, to allow it to start, and that's just one of these signals that we're seeing going down here now. Okay, so with that in mind, we know we've got they're good signals. Generally speaking, they need to mirror each other. The CAN high and the CAN low need to mirror each other with kind of square packets of data going down. So looking at that, I'm quite happy with that. You know, we've got ignition on, you can see dashes on there, and this is the data transfer going down the CAN network. So for us to do our R9T conversion that we're doing, what we'd really like to do, well, the customer would really like to do, is get rid of these, as we've said. So can these be removed? So what I'm going to do is, what we'll do, I'm going to turn the ignition off, and as I said, in fact, if I turn the ignition off, I wonder if we can catch this. Can we catch a block of data? It happens so fast, it's on 200 milliseconds data capture. Let's just see. I don't know whether we're gonna, oh, there we go. So if that just gives you an insight into a CAN signal. These are all just different sets of data that have been sent down on 200 millisecond scale, so you can see the speed. Okay, so what I'm going to do, I'm just going to come back out. We know the CAN signals are really good. If you saw these leaning, these square, if you saw them leaning, there's all sorts of different reasons why you can get failures, like a short to ground, a short to positive, a broken wire on the CAN high, CAN low. But anyway, they're all sort of diagnostic issues. But for us, what we want to try and learn here, or find out, is whether we can remove these clocks. So we need to find now where those resistors are, to see whether we can, the actual brain that the resistor's in, we can't remove. So we're going to go straight to ohms. We're on ohms. In fact, I might need to calibrate this. Just let me go back to, on this Verus, snap-on Verus here, the ohms measurements are done on port 3 and 4. Okie dokie, let me have a look. So just let me go back a second and see if it wants me to calibrate that. No, it's actually saying, I think, just 2 seconds, that calibration there. Do you wish to calibrate this probe? And we will do, so we know we're getting an accurate. So what I'm going to do, I want to take the wire out the back, and I'm just going to join. The probes essentially is our back probe. So as you can see, connect channel 3 and 4 together, which I've done. So it's now calibrating to 0. Okay, so now the reading we get is going to be accurate. So I'm just going to put that one back in there. And in the other CAN wire, I'm just back probe behind it. We're not doing any damage to the terminals. We'll just back probe behind. If we can get a reasonable. So our reading now we're on. Turn it off. Wait for it to shut down. For the modes or the nodes to shut down. And we are now, we've got 60 ohms measurement, okay? So what we mentioned before, 220 ohm resistors, when you've got two together, the resistance is halved down to 60. We've actually got 65. It's actually shutting down. It's a little bit of activity on the network, but it's shutting down. We're at 60 ohms. Pretty damn accurate at the 60 ohms, 5960. Okay. So what we've got now then, we've got everything connected. So what I'm going to do, I'm just going to disconnect, for instance. Okay. That is the ABS. You can see the ABS plug? I hope you can. The ABS, if you can't, the ABS plug is disconnected. I don't know if you could see that. Just let me show you. ABS plug. Okay, I'm going to put it back in. So the resistance did not change. The resistance is still, let me get it a bit closer for you. The resistance is still 60 ohms as it was when I disconnected it. So what does that tell us? We could disconnect the ABS from the bike. I'll do it again. There it is, unplugged. We're still at 60 ohms. Means that terminating resistor is not in the ABS module. Okay, so that's narrowing it down for the amount of systems there is on the bike. I'll pretty much guarantee that one of the resistors is in the main engine ECU. Okay, so what we want to do, we want to take the clocks off and just have standard clocks. So if I can do this without undoing these back probes, I'm going to try and take the plug out. And you know, you can never do it, can you? When it's such an awkward plug to get out the back of as well. Right, clock's off. Immediately we've gone north of our, in fact data now we're not, hang on, we've got a wire off now. So now the clocks are out. On a 400 ohm scale into the two measuring. So live data at the minute tells us 114. So 114 ohms, alright, it's a few ohms off the 120, but 114 ohms shows us that that resistor, that one terminating resistor, is in here. And if I can do it now to kind of reverse prove it, if you like, we're at 114 ohms watching live data. If I can get this to just plug in, and then immediately it plugs in, the resistor comes back online, back down to 58, and you can actually see what this tells us is, in simplistic terms now, is we can't remove the clocks. The clocks are an integral part of the bike's CAN network. It wouldn't work properly removing these clocks. As I said before, there's possibly some whiz-kid out there that can find that resistor on the printed board that's in the back of here or in this brain, okay, that can find all that and put it in a little, I don't know, a little module for us or something. But you know, I'm really not getting into that. For me, I just needed to know whether we could remove, see the network going back to sleep now on there, and it's back down at 60 ohms because we've still got the resistor in the clocks connected. So I hope it weren't too technical. I'm not an absolute master on CAN networks myself. I've just got an overview and an insight into how they work and what you can and you can't do. As I said, we've got, imagine that 120 ohm resistor is in that brain and that one is in that brain. This one in the middle, or however many were along the middle, you could remove and it would affect nothing. It just, there would be no module there to pick that data up. But when the terminating resistor is in, like I say, this is a brain, not just a set of clocks. So I hope that kind of helps, and anybody thinking about this in the future. So but yeah, there we go. So Project R9 is back to having standard clocks, I'm afraid. So okay, thanks for watching that, and thanks for coming on board with us. Next step, I I think next step now it really is starting to prep the paintwork, which should get interesting because we've got all the pinstriping to do, and yeah, load of prep, pinstriping. We've got the white pinstripe, the silver pinstripes, and the beautiful black colour that we've got for it, a BMW colour. So anyway, I'm glad you were on board for this one, even though it's possibly a little bit, I don't know, these things can be a little bit technical at times, but do you know what, it was just something I needed to do before I started chopping into anything. So again, thanks for watching, and we'll catch you on the next one. Cheers guys.